At the end of the day, you want to be able to write up your results and know the changes you see are real, and not the result of handling or pipetting error. This prompted our next question from Aneesh at the Rajiv Gandhi Center for Biotechnology, who asked, what is the best method to ensure reliable and reproducible data? Let's begin with our experimental plan. For instance, how many replicates do we really need to do? No one wants to use up more reagents than necessary. To keep reagents at a minimum, while still being able to catch any errors in pipetting, we recommend running triplicates. Let's look at an example to show why. Here is a set of replicates for our target. The CT values are 20, 19, and 37. Looks like maybe I forgot to add sample to this well, but that is not a problem. With triplicates, we can clearly say that the CT value of 37 is an outlier and should be removed. I simply click to omit, update my data by clicking Analyze Again, and voila! I can move on and still use this data point for the sample. But let's look at another example. What if I only ran duplicates? Now I have two samples with CTs of 22 and 31. That's a lot of variation in a replicate. I don't really want to average them, but I don't have any justification for using one over the other. Now I'm forced to omit the entire sample from my data. So now we've seen why triplicates are a good practice. But do note that there are cases in which replicates would not be required, such as large screening projects. In these studies, many targets are tested at once to find significant hits, and those hits are later validated with more scrutiny and more replicates. So how do we ensure that our triplicates are tight? Ideally, the deviation among replicates is less than 0.5 CT. Let's go through some recommendations for the best practices for tight replicates. 1. Make a master mix. Make a reaction cocktail of master mix, assay, and water. Calculate the amount needed for the total number of reactions, plus a 10% overage to account for pipetting losses. Thoroughly mix the cocktail by pipetting up and down 10 to 12 times. Mix again before use if the cocktail will be sitting around, so that the components don't settle out. 2. Dispense the master mix to your sample plate, and then add your sample. Make sure to mix by pipetting about 10 times, and not to reuse pipette tips. 3. Use properly calibrated pipettes. 4. Make dilutions when needed. Don't pipette unreasonable small volumes under 2 microliters. For example, instead of pipetting 1 microliter, make a 1 to 10 dilution and then pipette 10 microliters of master mix. 5. Spin down the plate before running. After mixing and sealing the plate or tubes, spin down to make sure everything has gathered to the bottom of the wells. Check to make sure there are no bubbles on the bottom of the wells either. 6. Aliquot reagents as needed to minimize the number of freeze-thaw cycles. We recommend making aliquots of primers or assays in order to keep the number of freeze-thaws to a minimum, ideally less than 10. Using these methods will help to ensure that your replicates are as close as possible, allowing you to be confident that the changes that you see are real. If you've got real-time PCR questions, remember to just ask TaqMan on Facebook, Twitter, or at lifetechnologies.com/ask TaqMan. Thanks for watching.